everyone, welcome to SWAM course on image processing using Python. My name is Bharti Patel, Assistant Professor, Computer Science and Engineering Department, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Today's topic is understanding image histograms and applying histogram equalization. So let's begin with the detailed description of today's lecture. So what is image histogram? An image histogram is a graphical representation of the distribution of pixel intensity values in a digital image. It provides a way to visualize how frequently each pixel intensity occurs in the image. The histogram typically has the pixel intensity values on the x-axis and the frequency or number of occurrence of those values on the y-axis. In a grayscale image, each pixel has a single intensity value ranging from 0 to 255. It means black to white. The histogram will show the number of pixels with each intensity value, indicating the overall brightness distribution in the image. For color images, the histogram becomes more complex as each pixel now has multiple intensity values, usually representing red, green and blue, which is called RGB channels. In this case, the histogram will be a three-dimensional representation, where the x-axis represents intensity values for the red channel, the y-axis for the green channel and the z-axis for the blue channel. Alternatively, a color images histograms can also be visualized using a two-dimensional plot by converting the RGB values to a single channel, such as grayscale or luminance. In image histograms, basically histograms are commonly used in image processing and computer vision tasks such as contrast enhancement, histogram equalization, thresholding and various other image analysis techniques. They provide valuable insights into the overall characteristics of an image and can help in making informed decision about image processing operations. So, visual representation of any image, what it means? A visual representation of an image means histogram is typically a bar graph where each bar corresponds to a specific pixel intensity value and the height of that bar represents the frequency of that intensity value in the image. So, the x-axis represents the pixel intensity values and the y-axis represents the frequency. It means the number of occurrence. So, in this figure 1 we can see it represents data visualization using Python. In this figure we can realize that there is two axes, x-axis and y-axis. X-axis represents the values or the pixel values and the y-axis represents the frequency. So, here is one example for image histogram to illustrate the concept. In this example or in this code, we can learn that how to implement or how can we visualize the histogram. So, in this we have to import the important libraries as we are importing the matplotlib. Here for importing matplotlib, we have to initialize the values with numpy also as a library function. In this, first of all we have to read the image by image read, then we have to do image slicing into 2D, after that x coordinate denotion, after that y coordinate denotion, after that title of an image, that is called original image. We have to implement this code on your system and we can realize that there is a functions which is going to give us the intensity value of that particular image. So, we have to plot that image with that histogram value. So, histogram for that particular image is here. So, we can realize in figure 2 that here that this particular image represent histogram representation of any image using Python. In this image we have taken a standard or benchmark image with correspond to that particular histogram value and which is denoted here with y-axis and x-axis. So, next is calculating image histograms. This is another term to calculate the histogram. So, in this topic we can realize that how to calculate the image histogram. Calculating an image histogram involves counting the frequency of each pixel intensity value in the image. The process is straightforward and can be done using any programming language with image processing libraries, which already discussed in previous lecture. So, we will demonstrate how to calculate the histogram of a grayscale image using Python and the popular OpenCV library. So, by this example we can learn that how to implement or how to calculate. So, first of all we have to import all the libraries like CV2, NumPy, Matplotlib. After that we have to load the grayscale image. Why we are using grayscale image? We are using grayscale image so that complexity will be reduced. In color images complexity is very high. So, here we are using grayscale image. After that we have to calculate the histogram values. Then we have to plot the histogram. We can easily plot by X label and Y label. X label denote the pixel intensity and Y label denote the frequency. So, in this code we can learn that if you need to replace grayscale image PNG as we have taken for this particular example with the path to your actual grayscale image, the code uses the cv2.imageRead function to load the images as grayscale, or we can say grayscale images have only one channel as it reduces its complexity. Then it uses np.histogram to calculate the histogram. The bins parameter specifies the number of bins. It means 256 for an 8-bit image, which is standard for grayscale. And the range parameter sets the range of pixel intensities, that is from 0 to 255 for an 8-bit image. So, the resulting histogram will be displayed using Matplotlib, that is called a library function for that particular example. After that, please ensure you have OpenCV and Matplotlib installed in your Python environment before running the code. You can install them using pip. So, this example is specific to grayscale images. If you have a color image, you would need to split the channels and calculate the histogram separately for each channel. Channel means RGB, like if we are using red, green and blue channel, so we have to specify that channel value, or you can convert it to grayscale before calculating the histogram. So, step by step explanation of calculating image histogram is here. First, we have to load the image. It means the first step is to load the image into your programming environment. You can use an image processing library like OpenCV in Python to read the image from a file. Make sure to specify that you want to read the image as grayscale, so it has only one channel. Second, flatten the image. What it means? The image loaded by OpenCV is a 2D NumPy array, always in the matrix form, but to calculate the histogram, we need a 1D array containing all pixel intensities. So, we need to flatten it. So, we flatten the 2D array to convert it into a 1D array using the flatten method. Then third step is define the number of bins and intensity range. We have to decide, or we can say decide on the number of bins you want for the histogram. For an 8-bit grayscale image, there are 256 possible intensity values. It is already known from 0 to 255. So, you typically use 256 bins to cover all possible intensity values. Fourth step is calculate histogram. That is our aim. So, for this we have to use the numpy.histogram function to calculate the histogram. This function takes the flattened array of pixel intensities and returns two arrays, the histogram values, it means the frequencies, and the bin ages. Fifth step is plot the histogram. That is optional, we can plot it, it is your choice that you want to plot or not. So, for this, to visualize the histogram, you can use a plotting library like Matplotlib. For specific purpose, we have to use For a typical specific purposes, we have to use multiple libraries. Here we are using matplotlib for a particular operation like plotting any histogram. So, plotting the histogram provides a graphical representation of the intensity distribution in the image. So, Python code example using libraries like NumPy and OpenCV is here. In this example, we can learn that how to import the library and how to perform the operation. So, first of all, we have to run this code. You please try on your system. First of all, we have to import all the libraries like import CV2, then import NumPy as NP, then after that import matplotlib, that is basically for plotting purpose. For this, first step is to read the image, then calculate the histogram with values, like here we are taking the calculating histogram with image and the value specified 0 to 55. After that, plot the histogram. Plotting histogram, it is very important. So, for that we have to use this plot and histogram. This is the function which is giving us the value for x label and y label. In x label, as we already discussed, that x label define the intensity level and the y label define the pixel frequency. So, next subtopic is visualizing image histograms. What it means? Basically, there are different ways to visualize image histograms. First is that there are various ways to visualize image histograms, each providing different insights into the distribution of pixel intensities in the image. And here are some common visualization techniques for image histograms. First is bar plot. We all know what is bar plot, but let us see what it means basically. So, the most common way to visualize image histograms is through a bar plot. In this plot, the x axis represents the pixel intensity values and the y axis shows the frequency of each intensity value. Each intensity value has a corresponding bar that shows its frequency. This is called bar plot. And next one is line plot, which is most commonly used. So, in line plot, a line plot is similar to the bar plot, but instead of bars, it uses lines to connect the points. That points are basically the connectivity of that particular object, which is representing the intensity values and their frequencies. This plot helps visualize any continuous trends or patterns in the histogram. So, this is called line plot. Next is step plot. What it means? The step plot is similar to the line plot, but somewhat different. How? We can see. The line plots are composed of horizontal and vertical segments, or we can say the points. We have to connect each point and we can get that plot. In this, we have to use that the composition of horizontal and vertical segments, which can give a clearer view of the histogram. But in area plot, that is the next one, an area plot represents the histogram as a field area under the curve rather than using lines or bars. It can be useful for visualizing the overall distribution and density of pixel intensities. Next is cumulative histogram. It is very important, we have to learn what it means. So, a cumulative histogram shows a cumulative frequency of pixel intensities instead of the raw frequencies. It can provide insight into the overall distribution of bright and dark pixels in the image. Next is 2D histogram. For color images or multi-channel images, a 2D histogram can be used. In this representation, the x and y axis represent the intensities of two channels. It means R and G. R means red and G means green. And the color or height of each pixel represents the frequency of that combination of intensity values. Next one is 3D histogram. A 3D histogram is an extension of the 2D histogram. A 3D histogram is an extension of the 2D histogram for multi-channel images. It represents the distribution of pixel intensities in 3 dimensions, where each axis corresponds to the intensity of one channel. It means RGB, any of the channel we can take either R or G or B. So, this visualization is more challenging in 2D format, but can be displayed using appropriate visualization tools. The next one is image visualization with histogram equalization. So, you can display an image alongside its histogram after applying histogram equalization. Histogram equalization is an image enhancement technique that redistributes the intensity values to improve contrast and enhance the details in the image. The next one is cumulative distribution function. This is very important because in every histogram we have to know what is CDF. So, let us start what is CDF. Rather than plotting the histogram, you can also visualize the cumulative distribution function, which is called CDF, of pixel intensities. The CDF shows the cumulative possibility of pixel intensities being less than or equal to a given value. So, next one is normalized histogram. A normalized histogram that scales the frequency values to range from 0 to 1, or we can say the range 0 1. So, allowing better comparison between histograms from images of different sizes or dimensions. Each of these visualization techniques can help to gain valuable insights into the image's pixel intensity or pixel intensity distribution and facilitate better understanding and analysis of the image characteristics. The choice of visualization image method depends on the specific analysis requirements and the type of image being processed. So, here it displays a line plot histogram to show another visualization approach. In this method, we can see that again we have to import the libraries, then again we have to read the image by image read. You can read any image with any type like JPG, PNG as we already discussed. So, calculate the histogram and that plot that histogram with that particular pixel value for plotting the line values or the points which are connected to make a line, or we can say for implementing line plot. So, in this figure 3, which is showing the example of basic line plot, we can see in x axis we have some values and y axis also we have some values. In x axis we can see the pixel values or the pixel intensities values, and the y axis is defining the pixel frequency values. So, by using this code you can implement or you can get this output. On your system you try to implement this code and get the output. So, next is understanding histogram equalization. So, concept of histogram equalization for contrast enhancement means histogram equalization is a technique used for contrast enhancement in digital image, or we can say computer vision techniques. The primary goal of histogram equalization is to improve the contrast of an image by redistributing the intensity values so that the full range of pixel intensities is better utilized. This can lead to more visual appealing and clearer images. The redistribution of the intensity values, it means we have to redefine the intensity values so that we can get the qualityful image. For that we have lots of method. By that method we can visualize our image more clearer. So, the concept of histogram equalization can be understood through the following steps. First is calculate the histogram. The first step is to compute the histogram of the grayscale image. Here again we are taking grayscale image for less complexity. As we discussed in color images, it requires the different channels and the slots for all the channels to enter the values. For grayscale we have a single channel. So here we are taking grayscale image. The histogram represents the frequency of each pixel intensity value in the image, that is called calculating the histogram. The next is calculating the cumulative distribution function, that is called CDF. The cumulative distribution function is calculated from the histogram. The CDF represents the cumulative sum of probabilities for each pixel intensity value. What it means probability? We have each pixel with some different values, or we can say the intensity values. So, for that particular intensity value we have probability to fetch that particular intensity value. So, sum of that probabilities is called that intensity value. So, it is essentially showing that how many pixels have an intensity value less than or equal to a given intensity level. So, next is normalize the CDF. So, the CDF is then normalized to scale its values between 0 and 1, which is the range. This normalization allows us to remap the pixel intensities to a new range. Actually, this remapping is using here to redistribute that pixel values for quality full image. So, next one is equalization of mapping function. So, mapping function is defined using the normalized CDF. Unless we do CDF, I mean the normalized CDF, we cannot perform that equalization. So, first of all we have to do that normalization. After that, this mapping function maps the original pixel intensities to their new values. The mapping ensures that the entire range of intensity values is well distributed, leading to improved contrast. So, applying the mapping function, how to apply we should learn. The mapping function is then applied to each pixel in the image, transforming its original intensity to the new value obtained from the mapping function, which is very much required for this particular task. So, the key idea behind histogram equalization is to make the histogram of the resulting image as uniform as possible, thereby spreading the intensity values across the entire dynamic range. In other words, it attempts to make the pixels in the image uniformly distributed in terms of brightness levels. Histogram equalization can be applied to grayscale images as well as individual color channels in a color image. Color channels, it means like for RGB, if we want to describe the color channels, then definitely it will be red, green and blue, and they have their different range of values like 0 to 255. For color images, it is common to convert them to a color space such as HSV, means hue, saturation and value points. Before applying histogram equalization only on the value channels, this is because equalizing the intensity components, or we can say value, that helps in enhancing the overall contrast of the image without affecting the color information. So, it is worth noting that histogram equalization can sometimes lead to overly amplified noise or undesirable artifacts in the images. Therefore, in practice, various modifications and adaptive techniques are used to control the contrast enhancement process and to avoid excessive amplification of noise. So, histogram equalization is a powerful and widely used technique for contrast enhancement, especially in cases where the original image has poor contrast or a limited range of intensity values. It is a simply yet effective method to bring out the details and improve the visual appearance of images. So, here this diagram shows the concept of histogram equalization and the CDF. In this diagram we can learn that first one is the original histogram. If we are taking some image and we are using Python code, in that code we have to import the file, it means the image, and we have to learn or calculate the histogram. So, first one is showing the original histogram value. After that it is converted into PDF, after that it is converted into CDF with normalization. After that the transformation function is using here, which is giving the different value or the different plotting for that particular histogram. Then we have to map the each point with that particular value and we can get the new histogram. So, from starting to end we can learn that how to convert that particular histogram of original image to our new histogram of the converted image. So, this is called histogram equalization. So, by code we can learn how to do this histogram equalization. First of all, we have to import the required libraries, that is import CV2 and import numpy as NP. After that we have to read the image, again we have to justify that which kind of image we are taking in which format. For that we have to use this function of image read, then calculate the histogram. This is very important, we should justify that the particular value with the range like 0 to 255. Here we are taking the calculate hist function for calculating the histogram. After that calculate the cumulative distribution function, that is called CDF, and we have to calculate the overall sum of that particular CDF. Then we have to normalize the CDF by using that normalize function, and after that we have to apply histogram equalization. This is our main target, to get that histogram equalization format. In this we have to interpret that image is flattened or not. We have to check that the image having that particular shape, and we have to use the function as normalized. After that we have to display the equalized image. Now our image is equalized, and by image show we can show the equalized image comparatively our original image, or we can say we can compare our original image with the equalized image. Now we have to understand what is adaptive histogram equalization. This is another topic which is very important to know. In continuation to equalization, we can learn that what is the meaning of adaptive histogram. So, adaptive histogram equalization, or we can say AHE in short form, which improves upon traditional histogram equalization by considering local neighborhood within an image, which is very much required to connect the points. So, the adaptive approach ensures that contrast enhancement is applied locally, addressing variations in lighting and enhancing details. So, a Python code snippet, or we can say by using Python, it is provided to demonstrate the implementation of adaptive histogram equalization using libraries such as OpenCV. So, some limitations are also there, that limitations of histogram equalizations. So, addressing noise simplification and artifacts. So, what it means? One limitation which is very much major for this. So, what is that? It is a possibility of amplifying noise during the equalization process. Additionally, artifacts may occur in highly localized regions, resulting in unnatural looking, or we can say unnatural looking enhancements. This slide explores strategies to mitigate these issues, such as adaptive approaches or post-processing techniques. So, evaluating histogram equalization results. After that we have to evaluate that result is proper or not. For that we have some methods to evaluating that equalization results. So, matrix for evaluating the effectiveness of histogram equalization. Matrix is a term which is very useful to evaluate the histogram equalization results. So, Python code which already shows the example of calculating image quality matrix for entropy, which is already given in this particular topic. So, what it means basically, the parameter result analysis. So, various metrics can be used to assess the effectiveness of the equalization process, such as entropy, mean squared error or structured similarity index. A Python code is representing or is providing to calculate image quality metrics, enabling users to quantitatively evaluate the improvements achieved through histogram equalization. So, this is the overall equalization process. After that, applications of histogram equalization. It highlights its usefulness in medical imaging, where enhancing the contrast of X-ray or MRI images that can aid in diagnostic. Additionally, it shows applications in computer vision, such as improving the visibility of object in low light environments or enhancing image details for object detection algorithms. So, conclusion of this topic is it provides a summary of the key points covered in the lecture, emphasizing the importance of understanding image histogram and histogram equalization for contrast enhancement. It also offers additional resources and references for further exploration of this topic, enabling the audience to deliver deeper understanding into the subject matter. Thank you.